Here is my first attempt to demonstrate part of, well, this will be part of Lab 20, part 1. I'm trying to do it with real hardware. So here is the Lab 20 handout. And here's part 1.1, the NMOS source follower. So in my box of parts, I picked out the RFP 50N06 and I wired it up on my little breadboard. And so the ordering of pins is gate, drain, source. So just like we had, well anyway, yeah, gate, drain, source. So remember, the gate is like the base, the drain is like the collector, the source is like the emitter. Here is a 1 mega ohm resistor going from the gate down to ground. Here is a 1 mega ohm resistor going from the gate up to +5. I would have liked +15, but +5 is the best I can do with this analog Discovery 2 board. We have these +15, -15, +5 volt power supplies that we bought. Unfortunately, they seem to be kits that you put together with a screwdriver and a soldering iron rather than complete power supplies. Oops, I wonder if that's true of all of them or just of the one I got. Okay, so that is what's happening at the gate. At the drain, we have a connection straight up to +5 volts, again, which originally would have been +15. And at the source, we have a 1 kilo ohm resistor down to ground. Then I have a 1 microfarad capacitor going from the gate over to my input signal source. As an input signal, I'm using with the, so here's the little key. So the waveform generator comes out on the yellow wire. So the waveform generator is going into the left side of the capacitor here. And so there's the waveform generator. And then I have the scope channel 1, which is orange. So scope channel 1 is looking at the gate instead of looking at the waveform generator, because it's sort of more interesting to see directly what's happening at the gate. And then scope channel 2, which is blue, is looking at the drain. The drain is the output for the source follower, just as the emitter was the output for the emitter follower. And now, with the Digilant waveforms software, first let me show you what I'm doing. So the power supply says, okay, I have the positive power supply on +5 volts. I have the negative power supply on 0. I don't need the negative power supply right now. And the waveform generator is a 1 kilohertz. I mean, we could have made it 100 hertz as the lab suggests, but it just powered up to 1 kilohertz. So there's 1 kilohertz sine wave, amplitude of 2 volts. So that really means amplitude. So that's 4 volts peak to peak. It says amplitude 2 volts. And then we'll go over to scope, and that's kind of cool. So we see the scope. So here is the gate, and here is the drain. And you expect that until you reach V threshold, the FET should be off, and then it turns on and starts following the input signal once it exceeds the threshold voltage. So from the gap between the gate and the drain here, gate and the source. Sorry, the gap between the gate and the source here. So VGS, right? The gap between the gate and the source. See, this looks like about 1.2 volts. This looks like about 3.7 volts. So it appears that V threshold is around 2.5 volts for this NMOS field effect transistor, which is not too surprising. So I intended for this to look a little better because we would be powering it from +15 instead of from +5. So you'll see that in the circuit lab simulation. Anyway, so now what I want to do to try to, so the gate is biased to 2.5 volts because I used a 1 mega ohm voltage divider. I think I can make this look a little bit better by instead using a 1 mega ohm, half mega ohm voltage divider. So I'm going to try to put two 1 mega ohm resistors in parallel from the gate up to the positive power supply. So then that should bias the gate a little higher, which should leave us up above V threshold more often. So I'm going to try that and start the next video. So that's it for this video. Oh, and by the way, just while we're here, the Slack channel for discussion is actually, it's really useful. So if you haven't signed up yet for the Slack channel, I would say definitely sign up. phys364.slack.com. You have to have the invite link if you're in the class. So it's actually, so far several people have got a pretty quick interactive help from us via either public message or direct message. So I think it is a pretty quick way for us to communicate with each other. Okay, so I'm going to end this one, and I'm going to try to bias the gate a little bit higher so that we don't see the waveform clipped quite so badly.